Hi there. When we wrote our previous firmware, we used Bluetooth Low Energy. This came with some limitations, some due to the hardware that we were using, like the fact that we were getting some interference from the Wi-Fi connection into the Bluetooth stack, but also some that were inherent to Bluetooth, like the maximum distance that you can use a Bluetooth sensor from the collecting station. For this firmware, we have taken a different approach. We are going to use Wi-Fi to connect to the collecting station. That provides us with some benefits, like the ability to cover a much greater area, particularly if we use access points to give access to the Wi-Fi. But it also comes with a price. It will consume more energy, and if we use batteries, they will last less. In practical terms, using Wi-Fi implies that we will be using TCP/IP-based communications. That opens a wide range of possibilities, but I'm going to summarize them into three in order of likelihood, from less to most, that we can adopt this particular approach. So we can go with a custom TCP or UDP protocol that we have to define ourselves and use it and implement it for this purpose. We can go with some existing protocol that is useful to exchange data. Although there are many, HTTP is the incumbent here, so probably that's the option that we're going to mention here. And finally, we can go with a protocol that is tailored for exchanging events, these events containing values, and to spread the values, others that are interested in those values. Creating a custom TCP or UDP protocol is expensive, time-consuming, and error-prone. So unless you have a very specific requirement that you cannot achieve by using anything that is already existing, my recommendation is not, and we are not going to take this way. HTTP comes to mind as an excellent solution to exchange data. REST APIs are an example of that. However, there are some limitations in the case of HTTP for our purposes. One of them is that the protocol is basically unidirectional. It means that our clients have to open a request each time they want to communicate data. And the data is a request from the client and the response from the server. There is also some overhead. Part of it because of that, of requiring a new connection every time, but also because of the protocol itself. Finally, there is another limitation, that is the inability to communicate, to spread the data when it changes to interested partners. And that is not part of the protocol itself in the case of HTTP. If we want to go with a solution that was designed for these kind of scenarios, MQTT is the natural choice. And that is not because it overcomes all the limitations that we were mentioning about HTTP for this kind of scenarios, but also because it provides some nice features for this purpose, like being able to remember the last known good value, or providing clients with the ability to show interest about a value or a set of values, which in this case are not referred as such. Values what is contained there, but the topics, that is where the data is published to. MQTT was designed and tested in the field with tons of sensors, and those sensors are changing their value very often. MQTT is a publish subscribe protocol that was designed with the scenarios of IoT in mind. And the server that we will be using for MQTT is referred to as the MQTT broker, and our sensors will act as MQTT clients for this broker. Now that we have a better understanding of how we are going to use MQTT to publish our data, we are going to create the code to connect to the MQTT broker. But before we are able to do that, we need to connect to the Wi-Fi. And in order to do so, we are going to write the Rust code that is needed to connect to the Wi-Fi. It is important that you take into account that this board only supports 2.5 gigahertz band for the Wi-Fi router. So if your router is only sending signal in the 5 gigahertz band, your board won't be able to connect to it no matter how kindly you ask. Also, take into account that unless you're a very wealthy millionaire and you bought yourself an island to follow along this content, it would be very nice to have a good password in the Wi-Fi and in the MQTT server.
I am going to start by defining a new struct that will contain the authentication data for my network. And I'm going to put this new struct here at the beginning. And this struct is going to be called configuration, as you can see here. I'm going to have two fields in it, one for the SSID and the other one for the password. We could set these fields in the code, but that would be a terrible idea. We will have to expose the secrets, particularly the password, and when anybody had access to this code, both here locally and also if I push it to any external repo in the cloud, GitLab, GitHub, or whatever, the password is going to be there forever. And I don't want that. Instead, I'm going to go with a solution that is shown by the Federal Systems people in their training for standard library programming for ESP32, which is going with this crate. This crate is called toml-config, and what it does is it brings data from a toml file that is called cfg.toml into the code. So it does a pre-processing and sets the value of whatever you have in this file to the structure that you tell it to do it. And the way you tell it to use the data is by using a macro that in this case is going to be this one. So we're going to use the macro here to flag this structure as something that has to be used by the toml-config crate. And you also have annotations here to provide the default values for these ones. Same thing for the SSID and same thing for the password. So far so good. Now we should take care of having a file for having this data in the file. Let's go to the terminal and let's first ensure that we don't push that file into the repo either, because it would be as bad as having the values in the code. So here I'm going to add the cfg.toml file to my .gitignore in this repository. That way, the file is never going to be accessed by Git, and it will never be pushed to the repository in the cloud, whatever I use. The next thing that I'm going to do is to create a file. So now by doing touch cfg.toml, I have created the file that I want to use in order to have my password and my SSID. And I go back to the editor here and I use my sidebar to find the file, which is here. And I go here and then I use this content inside of the file. In the content of the file, you have to verify that this is the same thing. Let me get rid of the side panel. This is the same thing that we have for the field in the structure. Let me show you that. So that is what we have in the structure, Wi-Fi SSID and Wi-Fi password. And I'm going to go back to the cfg.toml, and you can check that these are the same names for the fields. As for the name of this section here, it has to be the same name of the package that you're using in your cargo.toml file. So let's go to that. And here, let's open the side panel. Let's open cargo.toml. And you will see here that in my package, we have this name, exactly the same spelling that we're using there. So Mosquitto dash bzz with 2 T's and 3 Z's or 3 Z's. This is what we're using for the name of the package, which must be the same that we use here. There is one more thing that I want you to take into account. If you end this function and you don't return anything, the Wi-Fi object that you have created here will be deallocated here when you exit the scope of the function. So in order to keep that instance available and avoid deallocation and thus disconnecting from the network, you need to return that so it can be retained outside of the scope of this function. So we need to change the declaration of this function, and we're going to do so here. We're going to have a result that instead of returning nothing, in the case of no error, it will return ESP Wi-Fi boxed, which means that it's going to be allocated in the heap and that is going to be available to the outside world, to the function that calls this one. So now that we have changed the declaration, we can go and change the return. So here, instead of returning OK, we are going to return OK, but containing the ESP Wi-Fi boxed, as we said before. So now we have this in place, and we can use it in order to create a connection to the Wi-Fi. Let's go back to the function where we were reading the noise level. And here we were taking two parameters, the analog to digital converter and the pin that it was using. In this occasion, we're going to take a third one. This is going to be now the signature of the function. That notice that we are still taking ADC1 as the analog digital converter, the pin that it uses, and we're using the modem that is a peripheral that can be used for the purpose of connecting to the Wi-Fi. So this is what we're going to do. We're going to replace this declaration and use this one instead. That means that we have to create the instance of the modem inside of the main function. So we're going to do that here. Right after creating an instance of the pin, we are going to create an instance to the modem. And obviously, we also have to use it when we create a thread, because here we are only using two parameters while we need three. So let's go here and let's use this other implementation and remove the old one. So that is what we need to do in order to pass it onto the read noise level. We also have to use it there. So how do we do that? Well, the first thing that we want to do here is to get the configuration into a variable. We are going to read that configuration, and that is something that is going to be done basically by the toml-cfg crate. And here we're going to take advantage of that and have this configuration stored in this variable. Now that we have that, we can use it, and we're going to do it right before we start the loop. So here, at the beginning of the loop, right before it starts, we're going to invoke the function that we have created. So that would be this function that we have, the connect to Wi-Fi, and we're going to keep this in order to retain it. Let me reformat this so it makes more sense. And we are going to, in the case of a successful return, we're going to keep that and send it here. And in the case of an error, well, we're doing nothing. What we should be doing is we should log the error. We want to say, hey, something wrong happened. We couldn't connect to the Wi-Fi. Also, we would like to use the status to report that problem to the user. And we do that by having the status storing the Wi-Fi error enum that we created in the previous episode. And notice that we don't have the status here, so we have to add it to the declaration of this function. So we're going to do it here, and I'm going to put it here and remove the previous thing. So now we have the same function, but we have also the status that it was an atomic U8. We have to change the invocation of this function here when we create the thread, and that should be done by adding the status parameter and removing the previous invocation because that's not needed anymore. And finally, in order to have this up and running, we would like to remove the function that was changing the status, because let's go directly there. So the change status is not needed anymore. We are going to change the status when it makes sense, not randomly. So we remove this function and we go back to the main function. And here we should remove the creation of this thread. So that should be it. Now we have all the pieces in place, and we should be able to come back to here and say cargo run. And yeah, there's something I forgot to do. So let's go back to the code, and there's one more thing that we had to solve. So here, when we were creating the Wi-Fi, it's still telling us that there's a problem here. And the problem is because, in the case of this connected Wi-Fi goes well, it returns the Wi-Fi. But in the case it returns an error, then we are returning nothing. And that cannot be stored in a box ESP Wi-Fi. So what we have to do instead is to change what we return in each case. So in the case that we have no problem to connect to the Wi-Fi, we are going to have OK Wi-Fi returning some Wi-Fi, so an optional ESP Wi-Fi. We remove this one. And in the case that we have an error, what we are going to return for an optional is obviously a none value. So we couldn't get the proper Wi-Fi. Now, both branches, both arms of the match return the same type of value, an option to a box of ESP Wi-Fi. Now we can go back to the terminal, and here we can execute the program. And let me connect the board. And here we are going to use this, which is the same board that we were using before. We're flashing to it, and we should be getting an error very soon. So here, let me try to stop this and go back to the beginning of our error and see the kind of error that we get. That's very nice. This is a Stack Overflow, and not in the sense of the website that helps you solve your coding problems, but rather you are overflowing the stack. So how do we deal with this? We have to make the size of the stack a little bit bigger, because we're exceeding the size of the stack that is being used for the thread in which we create the Wi-Fi. Okay, so let's go back to the code. And the only thing that we are going to do is to replace the creation of this thread here, the one that we were using to read the noise, and we're going to create it using the builder, which allows us to do a little bit more. Instead of this code that we have here, we're going to create it like that. Notice that the spawn scope is going to be the same, but we have, let me remove the old one, the ability to use the stack size, a custom stack size here, in order to modify the stack size that we need. We can go back to the code here, and hopefully, if we run it again, it will be running without any issues, and it will be connecting to the Wi-Fi. Fingers crossed now, and let's trust that what we did was okay. It will take a while in order to connect to the Wi-Fi, and yeah, it did. So now it's sending values.
The next piece of code that we want to write for our sensor is the one that connects to the MQTT broker as a client. However, we don't have an MQTT broker yet. So let me tell you how to install an MQTT broker in one of your computers. In this case, I'm going to use the same Raspberry Pi that I will be using for the collecting station.
For this section, I'm going to need an MQTT broker. And in my case, I'm going to be installing the MQTT broker that is called Mosquitto. It is an open source project by the Eclipse Foundation, and it implements versions 3.11 and 5.0 of the MQTT protocol. I'm going to install this software in the same Raspberry Pi that I use for the collecting station. So this is going to be a Linux system. And here I'm going to upgrade the packages from the sources of Debian. And here I don't get anything new because I did an upgrade very recently. And I'm going to install the three packages that are required here. One is Mosquitto, the other one is Mosquitto Clients and Mosquitto Dev, which we won't be using today, but we will be using for the next episodes. So this is checking that the versions are exactly the same ones that I already have installed. And it allows you to have these packages ready to run, but you have to launch the Mosquitto server. So here, this is what I'm going to do. I'm going to use systemctl to enable this server in my Linux machine. I just run the command, say enable, and the Mosquitto server will be up and running. If we leave it like that, we can only authenticate locally. And that won't be useful to us because we are trying to access this Mosquitto broker from the ESP32C6 board that is the firmware that we're writing. So we need to access this Mosquitto broker from the internet. And in order to do that, I need to add a user and a password. The user in this case is going to be sound sensor, and that is the name of the user that we're going to be using. And the password is sapobam capo with exclamation marks between each of the words. The backslashes are just meant to keep the exclamation marks there. So this is the user, and I'm going to create a new configuration. The Mosquitto server will be attending on port 1883, and it won't allow anonymous access, and it will use the password file that we have just created. That new configuration is going to be stored in /etc/mosquitto/confd/remoteaccess.conf, which in this directory, in confd, you can put more than one configuration for the same Mosquitto server. So now that I have that, I can restart the Mosquitto server. We could have enable it right here, but every time you modify the configuration, it's recommended to restart the server. And here, what I'm going to do is to subscribe to a topic. A topic is any kind of event that you want to refer by name, and you will send values to that topic. In this case, hierarchically, this is going to be test/topic-1, referring to among all the tests, this is the topic one that I have as a test. I'm using user sound sensor and the password that I created for the password file. Now I have subscribed to this topic, and if I go to the other terminal, here I'm going to publish some value to this topic. And in this case, it's going to be the message that I'm publishing is Hola Caracola, and I'm using the same user, same password. And this is the sequence of messages that I'm sending. And as you can see here, the one that was subscribed got the message too. So that means that our MQTT broker is up and running.
Now that we have the MQTT broker in place, we want to connect to it using code from our sensor. So we are going to write the MQTT client and send data to the MQTT broker.
Back in the code, we are going to extend the structure that we defined before to hold the authorization data for the Wi-Fi, so it can hold also the information required to access the MQTT broker. So here we're going to define three more fields. One is for the name of the host, the machine that is running the MQTT broker. It can be a host name, can be a DNS name, or it can be an IP address. Whatever is that you can reach from the Wi-Fi network that your board is connecting to. Here we will have the user. In our case, we created the user sound sensor and the password, which is the one with the noises and so on that we created before. So we are going to apply this to the config toml, and here I'm going to add these three new fields: MQTT host, MQTT user with the sound sensor. This is the name of the MQTT broker in my system. and the noises without the backslashes, because now we are not in the shell, we are in a tumble file. So now we can go back to the code again, and we are going to define the MQTT client in the same place that we were accessing the network. Just right after we have connected to the Wi-Fi, we are going to add a piece of code for connecting to the MQTT client. This is going to be the SP MQTT client, which is provided by the ESP IDF framework. And here we are going to import the username, and it needs 3 parameters. This underscore CB means that we are going to use a callback, but we need 2 more. The first one is going to be a URL, and I'm going to define the URL here before we invoke the constructor. And this is going to be produced using the data that we have from the app config. So notice that, let me indent the code. If the user is empty or the password is empty, then we will just use the hostname preceded by the protocol, the MQTT. But if we have a proper username and password, we will use them in the URL for the MQTT protocol. By the way, this should be user rather than host. So MQTT user. Okay, so now that we have created the URL, we have most of the parameters that we need in order to create the instance of the MQTT client. And we are going to do so here. We are going to use the URL that we have just created, an instance of the default configuration, and a callback that will be invoked when we create the instance of the MQTT client. This is added by Visual Studio Code. So let's fix the code. Now it is properly indented and we have created the client. The next thing that we would like to do is to define the topic that we are going to use. And initially we are going to go with a constant topic. And this topic is going to be a string and is going to be inside of the home. These are going to be the noise sensors, and I'm referring to the first one. Notice that in this level, noise sensor, we're using a space, and that's perfectly acceptable. There is no slash at the beginning, but there is a slash between every level of the topic. With the topic defined, we can go and define a string for the message that we will be using in our code. And now in the loop, we can create a message and send it to the MQTT broker. So once we have done all the configuration for computation for the code and we have the values here, we are going to compute the message that we want to send. That should be here. So I'm using the DBs that I have from the previous calculation that we did in the previous episode. And now we are going to use those to print the data that we want. So that would be if we're sending the message to the client and we're going to import this QoS. So we're saying, using the client, publish this message to this topic with this quality of service. Like we want the message to be sent at most once, so it will be fire and forget. I don't want you to retain it, and the message, the payload of the message is what we have created with the decibels. That's it. If this goes well, we are going to print that with the message. If it is not working as expected, it will print a message saying unable to send MQTT message. And we don't need that anymore. We're going to get rid of this part here. And that's it. This is all we need to have in place in order to send the message to the server. As we did when we were running the code in 2 different terminals, we are going to need 2 terminals in order to be able to subscribe to the topic and to access the board and send the program to the flash so it runs and publishes the data of the sensor to the MQTT broker. So let's go and let's create second terminal here. I'm going to do it like this to have a split value here, and I'm going to use it to SSH to the Linux that is running on the Raspberry Pi. And here I'm going to subscribe to this, duplicating some of the parts of the string. Let me get rid of the things that we don't need. So Mosquitto and -t, the topic. So we're using a hierarchy here. Home is the root of my hierarchy. Noise sensor is one of the things that I can find at home. And this is referring to number 01 of my noise sensors. I'm using the user and the password that I created before, and that should be it. Now I'm listening to that topic, and if I go to the other terminal here and I do carguar, I will be running on the board the application that I have just written. So I choose the device number, and it is flashing the contents to the board, and now it is connecting to the network, and the values start appearing on both sides of my terminal. Notice that if I stop this one here, this means that I have disconnected from the monitor, but things are still showing up here because the board is publishing values.
I would like to finish this firmware by solving a problem that we won't have until we use 2 sensors or more. At this moment, our firmware is using a topic that is a constant to publish the data. That means that if we launch 2 clients and they run the same firmware, they will be publishing their values to the same topic. And we won't be able to know which value belongs to which sensor. That is not what we are looking for. So it would be much better if we can associate a different number to each one of the sensors. And that means that we're going to use some kind of unique identifier for the purpose of differentiating the sensors in the topic. They will be publishing to different topics based on this unique identifier.
So in order to have this function that is going to be able to provide us with a different ID for each of the boards, I'm going to create a new function after this one, and I'm going to put it here. And this function is going to be called getSensorID, and is going to return a string that is going to be unique for each of the boards. Inside of the function, and I'm not going to go into much detail here. Let me try to organize this. Inside of the function, I'm going to use this function here that is provided by ESP-IDF, and I'm going to import it. And this requires a mutable pointer, and it has no knowledge of safety in the sense of safety for Rust for a string. So it is considered an unsafe operation, and it has to be in the scope of an unsafe scope. So you now can run this function here. It won't allow you to run this function without the unsafe mark, which is a way of saying that this is going to be dangerous. Here be dragons, and you know about it. You have agreed that there might be problems with this, so you have to pay special attention to this. What we're doing here is we're getting either an ESP OK, which means that we are getting the right value from the function, and then we are formatting this value in a way that makes sense. And if we don't have this value properly formatted, then we will have to use it we will have to invent something. And I have chosen to have some hexadecimal things here that are relevant. But if you see this as a topic, it means that this didn't work out and that you're having some problem. Now that we have that, we go to the function where we were publishing the data. And here, where we were creating the topic, we are going to obtain this sensor ID. And we are going to use it to define the topic. That is not a constant anymore because we are defining the topic from a variable. And it's going to be home, noise sensor as before, and the different IDs for the different boards. This is the MAC address of the board that you're using. And they are created differently, so they will have a different MAC address, and number is going to be different. This hexadecimal number is going to be different. And with that in place, what you need to do is to modify when you were publishing the message. And here, instead of having this invocation, I'm going to replace it with this other one. So it's very similar, but notice that instead of using the topic that was a constant, I'm using a reference to the topic that is not a constant anymore. And that's it. Now we have all the things in place in order to be able to send the message and publish it. We go to the terminal again, and here we're going to subscribe to Mosquitto. And in this case, I'm going to do things a little bit different. Let me try to get rid of the duplication that Visual Studio introduces when just a second, we will get there. And that's it. So we are subscribing to the topic using the user and password that we did before, but the topic is slightly different. In this case, we are just saying, I'm interested in any topic that starts with home and noise sensor, and it's only one level more. That is what the plus means. If we wanted to go deeper than a level, then we would use hash instead. But here we are using the plus, which means things that are one level below this one. And now that we have this, we do the same thing. We do cargo R. Oh, cargo R. And I forgot to add this US, right? Let's do it. This trait cannot be used unless you import it. So let's go to the beginning of the file. And here I'm going to put this one here. And I'm going to get rid of this. So I'm going to try to change it, and now it is here, and we can go back here and compile it. Yes, this has to be imported too. No worries, we're getting there. So let's go to the function that we have created, and here I'm going to import this symbol, and that's it. Back to the terminal, third try, and with this bin, let's hope it now connects to the device. Yes, it does. And we're flashing the new version of the firmware that is including a different ID. And once it connects, we will be also watching the contents on the other terminal. And that is it.
In this episode, we have finished writing the firmware that sends the data to an MQTT broker. We use Rust for the purpose, and I hope I was able to show you that Rust is an approachable and useful language for this purpose. We created the code that let us connect to the Wi-Fi and then connect as a client to the MQTT broker and publish the data. We even got ahead of ourselves and solve a problem that will show up when we use more than one sensor. We use the MAC address of the board to have a unique identifier that is used as part of the topic to publish the data, so we can differentiate different sensors that are providing us with different noise values from different areas. And in order to do so, you wrote some unsafe Rust and survived the wilderness. Now you can go to the bar and tell your friends, hey, I wrote unsafe Rust. Well done. In our next episode, we will be writing C++ code again. We will be getting the values from the MQTT broker, and sending them to the MongoDB Atlas database in the cloud. So get ready. Stay curious, hack your code. See you next time.